Today we're going to finish up our lesson on 5.5 with integration for bases other than e. So again, I've kind of given you the formula here, and the hint as when you see a constant base, let u be the exponent. Okay, so let's go over a few of these problems. So in number 5, notice that I have a constant raised to a power, so I want to let a equal the constant, and u is going to be my exponent. So what I want to try to do is I want to try to fit this in an a to the u du rule. So if a is 7, I have that. If u is 3x, then du is a negative 3x dx. And remember how we've always done this. If du is a negative 3x, I need a negative 3x on the inside, so that means I need a negative 1/3 on the outside. Now I have everything that I need to apply my rule. What's the rule? The rule is a to the u on top over the ln of a on the bottom plus c. So cleaning this up, you might have everything on the top and everything on the bottom. Again, we're integrating, so make sure you include your plus c, and that would be your final answer. And number 6, if you have a constant as the base, that's what's going to be your a. Your u, try to make that your exponent. So again, if I take du, I get an 8x dx. I'm going to try to fit this into a to the u du rule. So again, this x and dx, we hope that that's going to be our du, so we need 8 of those on the inside, which means we need a 1/8 on the outside. Now I have everything I need. So the rule for an a to the u is a to the u on top and an ln of a on the bottom plus c. So again, this rule is a little bit harder than the e to the u, but just try to fit everything into the rule. So for number 7, let's see if that hint works out well. So I have a constant to a power, so I'm going to let a equal my constant. U is going to be my exponent. Remember, when I take the derivative of that, we hope that that becomes our du. So almost, but I need a 5 on the inside, so that means I'm going to 1/5 it on the outside. That means I have a to the u now. I'm going to look at my rule. My rule for an a to the u is a to the u all over what? ln of u. And since a is equal to 4, this should really be a 4 as well, plus c. I can do a quick check on this to see if this is right as far as the derivative. So if y equals 1/5 ln of 4 all over a to the 5 tangent of x, remember what the derivative is. The derivative of a to the u is a to the u times u prime, and then these will cancel each other out. So doing a definite integral, we're going to do kind of the same thing with the definite integral. This is our a, this is our u, so if a is 4, u is equal to x, du is dx, so I don't have to do anything extra with this. I should have a dx in there. So when I integrate, I'm going to get by rule a to the u all over the ln of 4. And instead of putting plus c, remember we put a 2 on the top and a negative 1 on the bottom. By the fundamental theorem of calculus, it says to plug in the upper value first, minus the lower value. Let's assume we don't have a calculator for it yet. So how would I write that? 4 squared is 16 over the ln of 4, and 4 to the negative 1 is 1/4 ln of 4. So now let's check with our calculator. So if I'm checking my calculator, I'm going to punch out exactly what I see. So if I punch that out, I will punch out 16 divided by the ln of 4 minus 1 all over 4 ln of 4. I can get a decimal. Remember, in calc, we're going to round to 3 decimal places, so this would be 361. And since it's a definite integral, we can use our calculator if we have it. You can see that I've punched this out, but let me show you how you punch it out. If we're using in the updated version, we can just punch it out exactly how we see it, and we can verify that this is correct. So work on some problems in the book. I will be back Monday. If you have questions in the review packet, just email me those, and I'll try to address those questions via email.